see the type of equations. Okay, first one is called molecular equation. Molecular equation. These are just different ways to write a redox reaction. So we'll take one example like CuSO4 aqueous plus zinc solid forms ZnSO4 aqueous plus Cu solid. Okay. Now, is this a redox reaction? For that, we have to find out the oxidation numbers first, like copper. Copper is having an oxidation number of +2. SO4 will have 2 minus charge. Zinc is present alone, its oxidation number will be 0. In ZnSO4, oxidation number of zinc is +2, and in copper, oxidation number is 0. Okay. So when we go from +2 to 0, there is a decrease in oxidation number. So decrease in oxidation number means reduction. This is reduction. And when we go from 0 to 2, there is an increase in oxidation number. So this is oxidation. So that confirms that it is a redox reaction. And if reduction is happening, that means oxidation will also take place. You can remember this point, that increase in oxidation number, increase in oxidation number. So how you'll check the increase? First, find the oxidation number of the element present on the left hand side of the equation. Then find the oxidation number of same element on the right hand side of the equation. If you are finding that there is an increase from left to right, then it is increase, and if it is decreasing, then it is decrease. So first one is left, second one is right. So increase in oxidation number refers to oxidation, and decrease in oxidation number is reduction. Now, when we are writing the equation like this, molecular equation, you'll not find any ionic species, but there are ions available. Like in CuSO4, there is Cu2 plus and SO4 2 minus. So whatever ions are there, you can ionize it, and the way of writing that equation will be called complete ionic equation. That is called complete ionic equation. Complete ionic equation we can find. So whatever ion is there, which you can ionize, CuSO4 will ionize to give us Cu2 plus aqueous plus SO4 2 minus aqueous plus zinc solid, forming Zn2 plus aqueous plus SO4 2 minus aqueous and plus Cu solid. Okay. Now, is there any ion which is present in the exact same form on both sides of the equation? SO4 2 minus is there, right? SO4 2 minus is present in the exact same form on both sides of the equation. So SO4 2 minus will be called spectator ion. Spectator ion. That ion which is present in the same form on either side of the equation. On either side of the equation. So what you can do, you can eliminate that ion, like SO4 2 minus will be eliminated because it is not actively involved in the equation, right? So when we remove spectator ions from the complete ionic equation, what we get is called net ionic equation. Net ionic equation. Net ionic equation can be defined as complete ionic equation minus spectator ions. Okay, so we can subtract the spectator ions from the complete ionic equation. What we get is net ionic equation. So net ionic equation you can state for this like Cu2 plus aqueous plus SO4, sorry, SO4 will not be there, SO4 we have eliminated, zinc will be there, zinc solid forms Zn2 plus aqueous plus Cu solid. So while balancing the equation, actually you need the net ionic equation only. Rest all the ions you can eliminate. So this will make your equation much simpler and balancing will be easier then. And after this also, if you want to divide the net ionic equation, you can do it in two parts. Net ionic equation we can break down into two halves. One is oxidation half reaction and the other one is reduction half reaction. Oxidation half reaction and the other one is reduction half reaction. Okay. So now in oxidation half reaction, which of the two were oxidizing? Zinc is getting oxidized and copper is getting reduced. So for oxidation half reaction, zinc is getting changed to Zn2 plus aqueous. So you can check the oxidation number change, like zinc is present in 0 oxidation number and here oxidation number is +2. So by how many steps oxidation number have increased? 2 steps. So by whatever number of steps oxidation number has changed, that many number of electrons you have to add. On which side you have to add, you can remember it like in oxidation half reaction, electrons are added on the RHS, and in reduction half reaction, electrons are added on the LHS. Or you can remember that electron is always added on that side which has higher number of oxidation number. So higher oxidation number is with Zn2 plus, so we'll be adding 2 electron over here. This is oxidation half reaction. Same thing you are doing. That is just a way to understand. Okay. So when we go in this Cu2 plus aqueous and we are forming Cu solid. So oxidation number over here is +2 and oxidation number over here is 0. So there is change of 2 steps. It is being reduced, so 2 electron will be added to it. Okay. So these are the 4 different types